Unit 1A, Problem 7b, find the inverse of the function and state any inherited domain. When I do that, the first step that I need to do is find out if it's a one-to-one function to see if its inverse is going to be a function. And to do that, I'm just going to graph the square root function. I see that the parent function, the square root parent function, has been transformed. Here's my h value and here's my k value. So I know that it has been just transformed left 2 units and down 3 units. So I am going to put my point right here at a -2, -3. And from that, since it hasn't been stretched or compressed, I know that my square root would go up 1 over 1, and then the next point would be up 2 over 4. So I'm going to add a couple of tick marks and go up to here. I'm going to draw my square root function, or if I don't want to draw it, I can always graph it on my graphing calculator. And then I'm going to see, does it pass the horizontal and vertical line test? So here's a vertical line test coming down, and I see that no matter where I draw a vertical line, it only passes one y value, so that's good. So then I'm going to do the horizontal line test, and I'm going to go here, and I see that only one x value is crossed to one y value, so I know that it passes both the horizontal and vertical line test, so it is indeed one-to-one. At this point, what I'm going to do is then I'm going to state my domain and my range. And the reason I want to do that is because I'm in a case here where I'm going to have an inherited domain, and I also know that when I find the inverse of my function, the domain of my original function is going to become the range of my inverse function, and the range of my original function is going to become the domain of my inverse function. So here's my domain, and of my original function is x is the element of all real numbers such that, and this is where the starting point helps me, this -2 is my x value, so x has to be greater than or equal to this -2. And for my y value, that's where this -3 at my starting point comes in. I'm going to have y as the element of all real numbers such that y is greater than or equal to a -3. And there is my domain and range. The second step of finding my inverse function is to actually solve for the inverse. So we're going to do some algebra here. This is step 2. I am going to replace the f of x with the y just to make this easier. So I'm going to have y is equal to the square root of x plus 2 and then a -3 outside the square root. Now to find my inverse, I have to flip my x and y. So everywhere I see a y, I'm going to put an x, and everywhere I see an x, I'm going to put a y. So I have this y, x is equal to y plus 2 under the square root, and at the end a -3. Now, so that I can take this square root, my goal is to get the square root off of the y so that I can solve for y. But to do that, I need to get everything off the square root first. So there's this little -3 hanging off the end. So I'm going to move that on to the other side. So I'm going to have x plus 3 is equal to the square root of y plus 2. Now, to get the square root off the y plus 2, I know my students were really good in class when I asked this. Almost everyone told me what to do. I need to square. If I square a square root, it takes that square root off. It kind of cancels that out. So I'm going to, but if I square this side, I have to square this side to keep my equation equal. So now I'm going to be left with x plus 3 squared is equal to y plus 2. And y still isn't quite by itself. I still need to do one more step. I need to subtract this 2 from both sides. So I'm going to do that, and I'm going to end up with my final equation. Y is equal to an x plus 3 squared minus 2. And that's going to be my equation, my inverse function equation. From my previous slide, I know that my old domain is here, and here is my new inverse function. My next step then is to change this y. Since I knew that my original function was one-to-one, I know that my inverse is also going to be a function. So I'm going to turn this y into function notation, and the inverse of function f is going to be f of x is equal to x, where x plus 3 squared minus 2. that's one of my first steps. Now I need to figure out the domain and range, and we're going to talk about why this is an inherited domain and range. So I'm going to draw a quick graph, and I see now that my function is a quadratic, and I'm going to go ahead and draw this. This quadratic has been transformed left 3 and down 2. So I'm right here, and from here I'm going to go up 1 over 1 on both sides, and then up to 4. So here and here. And I'm not going to draw the curve yet. I'm just going to draw this piece. So my quadratic looks like this. But my square root function, when I had graphed it, it looked like this. And it only actually had one side. And so if I look at the definition for an inverse, and it states that I have an ordered pair AB, and it has to match the inverse's ordered pair BA, the problem is if I drew this side, this right side, and I'm going to draw this in dash marks, and if I had this side in blue, the question is, if this was my original function, which points would match up with this graph? And the answer is that it would actually only match up with this side of the graph. And so to keep it as an inverse function, I just actually can graph this side of the quadratic. And so when I have this function, I would have an inherited domain. So my domain is going to be inherited from the range of my previous function, and it's going to say, for this function to be true, my domain has to be restricted where x is the element of all real numbers, such that my x, even though it's a quadratic, and normally the domain for a quadratic is all real numbers, in this case I have to limit my domain, and the x is just going to be where x is greater than or equal to a -3, which is this right hand side of my quadratic, and that is my domain. And then my range for this function would be where y is the element of all real numbers, such that, and here's where I'm going to take that range for my domain up here, where y is greater than or equal to a -2.